Hello, everyone. Welcome to this webinar about Cloud HPC and cfMesh integration. This is Ruggero Poletto from CFD FEA Service. I am here today with Franjo Juritins from Creative Fields, the owner of cfMesh. And today we are going to talk about the integration of cfMesh into our Cloud HPC facility. So let's start. We have a presentation. Then we're gonna make a practical example of how this integration works. And at the end of the webinar, you are going to have time to make questions both to myself and to Franjo. During the webinar, at any time, you can use the chat on the right-hand side of the YouTube video to interact with us. So you can make questions, and we try to reply as clear as possible to any request of clarification you might have. Feel free to don't hesitate to write anything. There are no, every question can help us being as clear as possible to you and as satisfactory as possible to your requests. So let's start with a brief introduction of CFD FEA Service. We are an Italian company. We are based in Italy, in Verona, actually. Among the services we create, there are obviously software development, in particular as far as engineering is concerned. We obviously have our Cloud HPC facility. We're going to talk together later. And we do some consulting activity, in particular in the engineering field. What actually is Cloud HPC? Well, in few words, Cloud HPC is a cluster, so quite a high number of computers that are dedicated to run high CPU demanding software. When you run a CFD simulation in particular, but most of engineering analysis in general, you need to have quite a big amount of hardware resources in order to calculate and compute the simulation to the end. Well, most of the times these hardware resources cannot be available on your local computer or can be busy doing some more things. So you might interact with an external cluster, which is let's say, which is dedicated to compute this type of analysis. Why having this cluster, this computing cluster external can be a benefit for you? Well, first of all, there are 4 points basically. The first one is to speed up your simulations. In particular, if the size of your simulations in terms of domain, in terms of meshes, or in terms of modeling involved to your analysis is very big, total number of cells very high, for instance, you might need a very huge amount of hardware resources to speed up your analysis. Secondly, obviously, you can keep the focus on your on the engineering, so on the designing part, and we take care of all the IT infrastructure parts. So we just guarantee the cluster is available online, has been upgraded with the latest release of the software, with the latest hardware, all right, and there are no power breakdowns and stuff like that. Eventually, it's very important you just pay for what you use. We're going to see later in the pricing scheme we have a pricing which computes the amount of hours you spend on the cluster, and you just charge for that. And obviously, the system is always ready for your simulations. Okay, so you don't need to install software. Everything is ready to be used for your analysis, for your engineering analysis. The main feature of the Cloud HPC cluster are obviously the scalability. This is the possibility to reduce the computational type, so to use a higher number of resources to get results in a shorter time. This scalability is both horizontal, so it means that we can run several scenarios at the same time, so get the results of several scenarios in the time required to get one single scenario. result. And we also have a vertical scalability. So the bigger is your case, we can decrease the time required to get the results for that particular case. We have the possibility to use both OpenMPI, so multi-core parallelization, and OpenMP, so multi-thread parallelization. But it is important to note that the availability of these two, let's say, parallelization types depends also on the software you're going to use. And openFoam only allows to use a multi-core parallelization. So let's say your parallelization type is restricted to the first type. Among the software available on the cluster, there are several. We are going to mention only a few of them. We have Blender, Calculix, and Codester. These are quite famous for FEA analysis, or finite element structural analysis. As far as the CFD is concerned, we have FDS by NIST and openFoam. We're going to talk later about openFoam because it's highly integrated with cfMesh Plus. Among openFoam versions, we have quite a few of them, both from the openfoam.com and the openfoam.org side. Okay, so you can set up your case for any of these openFoam version and just execute it. It is also possible to install some custom-made software. There are 3 of them mentioned here. They are not available in all openFoam versions, but just in those mentioned here. But they allow to do injection molding simulation, humidity air simulation, and so on and so forth. So if you have a specific software you want to install on the cluster, well, it's something feasible. It's something that can be done. Also, like having it restricted to your account only. As a post-processing, obviously, it is possible to use ParaView, and this can be used directly on the platform using a remote desktop session, and we're going to see that together, how to do that. As a connectivity, this is like what I was mentioning right now. It is possible to both a VNC connection, so a remote desktop connection. This is easy to set up because it's directly in the browser, so you don't need to install anything on your local computer. So directly on the browsers, you have access to remote desktop, so it is possible to interact with the machines where your simulation is running. If you are more into programming, it is also possible to have an SSH connection and enter the machine using a terminal, enter the machine where your simulation is running, use the terminal, and edit the files or execute some custom commands. Okay, so that is feasible in both ways. In particular, SSH is very good if you're looking for automations in your workflows, if you want your simulation to do something particular at a certain point. You can create your own script, connect via SSH, and execute that particular script on the cluster. Among the other features, we have a full set of API. So it is possible programming your own workflow and interact with the cloudHPC using API. So actually, you don't need to click anywhere. We have a great Linux integration. We call it cloudHPC exec. And it's a Unix package you can download on your computer, install on your Ubuntu machine, and actually use that in order to interact with the cluster using the API or using many functionalities, including the script. And obviously, we have support available from 9 to 6 p.m. Central European time or summer time, depending on the season. And we give support both from the IT part, and we also try to give some help also in setting up your cases. Like if you're having troubles with your openFoam analysis, probably we can give some hint on that for that. Let's enter about the core topic of today's webinar, which is cfMesh Plus. This is a software developed by Franjo. It's designed to generate mesh for openFoam, but not only for that. Okay, so it's quite a complete mesh generator. It has a user interface. So for those of you who are used to Snappy, probably Snappy, let's say the original one doesn't have a user interface, even if there are some available on the web. Well, cfMesh has a user interface which allows you to upload a CAD file and set up your mesh in an easy way, so with few parameters, and generate your mesh for openFOAM case. In general, the cfMesh is able to generate meshes, but with high quality meshes, okay, I must say. So in the end, the advantage is also the fact that your openFOAM analysis in particular is going to converge in a very short amount of iterations, in particular for steady cases. And at the same time, the mesh generation is quite flexible to set up to several CAD geometries or to several edges or particular features of your geometry, which usually they tend to generate poor quality meshes, okay, at least locally poor quality meshes. The setup is straightforward. So using the guide, you are actually guided through the setup your mesh, and we're going to see later how. But with a very a low number of user input, it is possible to generate a mesh. And obviously also the time required to generate a mesh is quite short, both in terms of computing time, but also in terms of human time. So the time the human needs to interact with the software in order to generate a mesh. It is also possible, if you need to generate more and more meshes, to have a batch mode, so a scripting part which allows to automate the workflow. This is particularly useful in designing part if you use CFD as an optimization tool. Okay, having a batch mode to generate a mesh really speeds up, really can automate your workflow from scratch. This is just a quick overview of how the meshes looks like and what are the main feature of cfMesh Plus, and not mentioning all of them, obviously, but obviously the basic feature are present. So there is a core mesh inside, there is a boundary layer. You can control everything. You can control cell dimensions, you can control boundary layer, the number of layers in the boundary layer. You can control the ratios of the layers in the boundary layer. So it's quite flexible. Also, the overall quality of the mesh tends to be very high. If you see, it is possible to generate a boundary layer all around the geometry. There is no any type of interruption of the boundary layer that sometimes may happen, in particular during at the edges of your geometry. And another feature is that it is not just an hexahedral mesh generation. You have also a tetrahedral one. Here we have an example. You see at the center, at the core of the mesh, you have tetrahedral cells, and a polyhedral one. All right. So it's also very flexible because it allows you to generate different type of meshes using the same user interface. How the workflow of cfMesh Plus works on our cloudHPC? Well, it's very easy because, again, everything starts from a CAD file, which needs to be generated on your local computer. So you need to create the geometry in your local computer. Geometry must be an STL or other triangulated surface mesh file. Once you are happy with that, you can upload the STL file on the storage of the cloudHPC and execute a static instance with cfMesh Plus Guy enabled. We're going to see that later, how to do it. Once you have done that, you can enter the remote desktop of the instance and execute cfMesh Plus. So with this execution, you can actually upload the STL file. We upload in cfMesh the STL file we uploaded on the cloudHPC and actually generate your mesh. Okay, so that's quite like having your own computer. At the end of the case, when you're happy with the mesh generated, you can just stop the static instance with cfMesh GUI enabled and complete the setup of your CFD case. I'm just wondering with openFOAM, and you can execute openFOAM directly on the cloud. Okay, so that's another good thing. And when openFoam is over, the CFD simulation is over, you can download the results to your local computer and you can execute part of you on your local computer. Actually, this very last step can be made also on the cloud HPC, but most of the people prefer to download it and have a local, also like for backup of the data, have everything on your local or your on their own computer. Let's have a look at an example on how you can do everything we said so far. So yeah, now I switched, and now this is the applications, the cloud HPC applications. Obviously, once you register, you are gonna given a username and a password. Using that, you can enter the web application. That consists basically of 3 pages. There is a dashboard which reports the overall use of the web application over the past month. There is a simulation page in which you have a summary of all your simulation that ran recently or ran in the past years or months. And obviously, you have a storage, which is the file exchange between your local computer and the cloud HPC portal. Well, the first thing we need to do is on the storage, upload the geometry I prepared on my computer. So in here, I just use the drag and drop feature. 1 second, I'm opening my desktop and I'm getting the file of the geometry. There it is. I just drag and drop from here and just drop it here. 1 second, it's not arrived. Yeah, you see, I just generated a zip file and I just named test cfMesh. So that is going to be like the folder name, and that is going to be the zip file inside of the folder name. So I just press save. I just wait for the upload to finish. Usually it takes a few seconds. It depends a little bit on your connection speed. And there it is. We have this test cfMesh folder inside of which we have the zip file we just have uploaded. Then we go to the simulation page, and the second thing we had to do was to execute a machine using cfMesh as a GUI. So I just can select the number of virtual CPUs of my machines. Like I want an 8 virtual CPU machine. I can select the RAM size of my machine. We have 3 RAM size, like 1 gigabytes per virtual CPU, 8 gigabytes per virtual CPU, and 4 gigabytes per virtual CPU. And in all of them, you have enabled both openMPI and openMP, so multi-core and multi-thread approach. If you want a multi-core only approach, you have a high core, which gives you 2 gigabytes per core, so only physical core are going to be allocated. And the folder, I'm going to select the folder we just generated, and on the script, I'm going to select cfMesh plus GUI. So this gives me a machine with cfMesh GUI enabled. Okay, so if you want to use cfMesh, this is what you have to do. So connection issues over here. Now you should be able to hear me. If you can write that on the chat, that would be awesome. I think I can move on with, let's say, the simulation. Basically, I was saying that in here I have the virtual machine. Every simulation is actually made available on a virtual machine, which is dedicated only to that particular simulation. Okay, so you can at any time have access to the virtual machine. And if I just refresh the screen over here, you can actually see that at the bottom, we are going to get access to the virtual desktop. All right. Yeah, sorry. All right, I'm just using the machine on the other side. Sorry for the issues with the internet connection over here. All right. 1 second. Yeah, we can use this. So in here, you can actually see that we have the simulation running and the virtual machine over here. On the virtual machine, we have available really the remote desktop, and we can use this remote desktop to interact with cfMesh. If you see in here, on the desktop, we have 2 or 3 icons. In particular, we have the cfMesh icon. If you double click that, automatically you are going to execute cfMesh directly on the virtual machine, and you can open your project or do whatever sort of interaction with the virtual machine. It's like having the computer on your own. So I would let now Franjo talk about the cfMesh functionalities and run an example directly on the virtual machine we just created. So Franjo, it's up to you, really.
Hey Roger, can you please connect me to the virtual machine? I'm basically just getting this connect button, so I'm clicking on it, but still not connected to the machine.
Okay, I'm sending you that.
Okay, now I've managed to connect.
All right.
Right, so basically regarding cfMesh, so it's designed that you actually first start the project, and inside the project you can create cases. So when you create the case, you can then import your geometry, which you have uploaded onto the platform. So you can either, when you import surface, you can upload either STL or native FMS formats. For CAD import, you can use step files, IGESs, or BRIPs. So the idea of the interface is that when you have your geometry, that you can actually load it in the GUI, and that also it enables you to navigate and set up the case as soon as possible. So the idea is, for example, if you don't know what parts you have in the mesh, so you can basically just click on here, and it simply shows you basically what patch you're clicking at. So then when you're actually setting up your meshing job, which is done here in the settings tree, so the idea is that you go here in the ribbon from left to the right, and in the settings tree from the top to bottom. Now, you also have additional tools which can help you basically during the setup process. So in this case, you can either check your surface mesh, you can scale the surface mesh, you can remove parts, copy parts, do some bits of editing, and then when you're happy how your surface is set up, when you have all your patches set up correctly, you can actually start setting up the meshing job. The idea of the GUI is that actually it helps you to generate the setup. So if you want to check your setup, you can always go under here, edit dictionary, and which will basically get you into what people in openFoam know is a more familiar word, where you have the keywords and dictionaries with all your setup you provided basically to mesh the case. And then when you're happy with the setup, so then you can go here under the measure tab and then run the measure. So for example, with the measure, you can basically create 3D Cartesian meshes, 3D polyhedral meshes, 3D tetrahedral meshes, and 3D all hex meshes. And you can also generate Cartesian 2D meshes. For the Cartesian meshes, your geometry has to be a ribbon. So today, I've basically just created a simple case to show you really what the workflow could be like. And also here if you want to learn how to use the software, so you can either go to online documentation or open a PDF documentation and basically just get the user guide and read in the user guide what are the features, what each button means, and how to use the software. And you also have some examples which you can basically tutorials go from the beginning till the end until you generate your first meshes and get an idea how the software functions. So let me just show you then when the setup is ready. So you just go and say, okay, I want to generate the Cartesian 3D mesh. So now basically your computer starts working. What I want to say is that basically cfMesh Plus uses openMP for parallelization. So we use multi-threading parallelization. So when you actually start, you have available, and it uses all available cores on your machine. So you see now basically we've generated the mesh. So now when the mesh is written, I can close this tab. It also basically saves the log file. So all the log files or the utility that you've executed is available in the case that you've generated. So now I'll close the surface mesh and open the volume mesh. So I can so you can see basically we've set up the boundary layers at the walls. So what we're really proud in cfMesh is of the effort we put into cfMesh Plus into boundary layer meshing, where we really want to get the smoothest possible transition between the boundary layer and the mesh, and to get the best possible boundary layer quality which can be achieved for your setup. In this case, this is a small geometry for demonstrating the software, so it can't be hugely complex. So for example, if I want to visualize the mesh inside, so I can simply clip it and just investigate how this looks like. So that's basically the features in a nutshell. So for example, for a lot of you who want to actually use the optimization, the GUI is mainly intended to be used just for basically, let's say, setting up a first case, and it can also assist you in making your setup as quick as possible. So for example, let me show you some features which you may find useful. Let's say if I want to let's say set up some refinement. So I can say, okay, I'll go to patches and I'll say I'll want to refine for the walls. And you can also here say show cell size, so it will immediately show you basically the cell size which you apply in this case. So this can be quite useful for when you're setting up a big problem, that you can actually visualize what is basically the cell size you're applying there. So in that case, it gets you basically much less time to get to the setup that will generate a nice high quality mesh. Maybe one more thing I wanted to show you is, let's say if you want to work in batch mode. So this is basically the case we've been working on so far. And is this installed in CF? Yes, in opt cfMesh. So there we go. Mesher bin. Cartesian mesh. So if you basically do this, we will basically start now generating the same mesh, but in the batch mode. So when you program it in a script, so you can basically do your first setup with the GUI and then continue basically using the mesher in the batch mode, and everything will run without any user intervention. So when the mesh is ready, you can simply start the solver on that mesh. So this is in a nutshell what I wanted to say about the how to use the software and how you can either use it in the GUI or in the batch mode.
Yeah. So if Franjo, your part is over, I carry on with the latest slides of the presentation. So I just go back to the slides. Well, after you have generated a mesh, it is possible to execute the CFD analysis using openFoam. Obviously, you need to integrate the mesh itself with the missing part of the information that are required for openFoam. In particular, the content of the zero folder, for instance, with the initialization and boundary conditions for the CFD. But I'm also thinking about the fluid dynamic models like turbulence, like compressibility of the flow in case you have compressible flows, or also the numerical schemes which needs to be defined under the system directory. And these, they need to be made as usual, but there are a couple of things to keep in mind if you want to run your openFoam cases on cloudHPC. There are actually two things in particular. One is how to generate a decomposed pardict file. This is the fundamental file in order to tell the cluster how to decompose the mesh. And well, it's very simple. You need to have method scotch and a certain number of subdomains, which is automatically adjusted by cloudHPC. So you can put any number over here. It doesn't need to match the number of the virtual CPUs you're actually using. Eventually, you also need to modify slightly the control dict file, which is again available under the system directory, by specifying the application. So the application you want to use, simple form, pimple form, compressible form, or whatever. All right. And this is mandatory. And then another thing which I recommend as an openFoam user is to add what we call the function objects. Okay, these are tools that tell openFoam to generate, let's say, CSV file with information of your running analysis, like the maximum of velocity, pressure, and temperature all over the domain, like the Y plus, okay, or the residuals, okay. Using these function objects, they are very useful because you automatically generate a CSV file, I simplified that a little bit, which can be open in Excel, okay, and gives you access to this type of information. Just pay attention that sometimes these function objects are different if you are using the openfoam.org or the openfoam.com. Okay, in particular, just referring to the residuals, the first formula, the first part refers to the openfoam.org extraction of the residuals. The second part, the solver info, refers to the openfoam.com. Okay, so it's important just to keep under control which version of openfoam you're using. Well, having a look a little bit at the prices of the whole application, everything is on consumption, so you can use the platform as you are normally used to do it, and there is a certain price depending on the virtual CPUs you are using and the RAM you allocate to the virtual CPU. Okay, let's say in few words, we can say that for openFoam, the lowest price is 0.05 euro per virtual CPU hour. And this gives you a 2 gigabytes of RAM per physical core. Okay, so that can be used. And on top of that, it is possible to use cfMesh Plus for €3 per hour. Okay, so that's an extra cost just for using the software. It's like a license renting cost for the software. With this, the presentation from my side is over. I remind here of the main contact you can use in order to get in touch with us, and also of the link you can use in order to register to the platform, to the cloudHPC platform. You need to go to this website, and at the top there is a registration button. It's worthwhile remembering that in this period, for all the new people that are registering to the platform, we are giving 300 free of charge CPU hours just to test the whole application and the software installed on the application itself. So if you want to use that, I recommend to register right now, right after the webinar. It's free of charge and allows you to use the platform. I'm not, with this, let's say the presentation is over. I'm not seeing any particular question in the chat. I hope it's because we were satisfactory in the presentation and not because we have been boring or something else. I think the topic is quite important. Meshing and CFD is very a huge important topic. And if you want, you can get in touch also later using the email address you're having a look at right now. And both me and Franjo, I guess, we are more than open to confrontations with you and to discuss also about specific simulations you might want to run on our cluster. Well, I see no more questions are coming. So with this, Franjo, I say the webinar is over. I'm really pleased to having held this webinar with you, Franjo.
Thank you.
I'm pretty sure
Really
we're gonna
enjoyed it.
have some more possibility to do more things in the future together. Also about maybe future interactions. And so I say hi to all the participants. And I don't know, Franjo, if you want to add anything.
First of all, I'd like to thank everyone for attending, and I hope you enjoyed the webinar. And of course, if you have some questions, do not hesitate to contact us. We'll be glad to answer your questions and hopefully resolve all your concerns if you have any.
That's okay. So I say hi to everybody and keep in touch in future. Bye.
Thank you. Bye bye.